Black holes are strange and fascinating objects in space. Imagine a place with gravity so strong that nothing, not even light, can escape. That's a black hole. Picture a giant vacuum cleaner in space. It sucks up everything around it, like gas, dust, and even stars. Black holes are not really holes, though. They are incredibly dense objects with a lot of mass packed into a small space. How do these cosmic vacuum cleaners form? Most black holes are born when massive stars die. Think of a star much bigger than our sun. When it runs out of fuel, it collapses under its own gravity. This collapse creates a supernova, a giant explosion that blasts the star's outer layers into space. The core, however, keeps collapsing, squeezing itself into a tiny point. This point is so dense and has such strong gravity that it becomes a black hole. Imagine approaching a black hole. As you get closer, the pull of gravity gets stronger. Eventually you reach a point called the event horizon. The event horizon is like a one-way membrane around a black hole. Once you cross it, there's no going back. Not even light can escape the event horizon. That's why we can't see inside a black hole. At the center of a black hole lies a point called the singularity. This is where all the matter inside the black hole is crushed. Think of the singularity as a point with infinite density, where the laws of physics as we know them break down. We don't fully understand what happens at the singularity. It's a mystery that scientists are still trying to solve. Section 5. Spaghettification, a very long stretch. What would happen if you fell into a black hole? Well, it wouldn't be pretty. Imagine a giant stretching machine. As you fell towards the black hole, the gravity would pull on your feet much stronger than your head. This difference in gravity would stretch you out like spaghetti, a process scientists call spaghettification. Don't worry, it's not a pleasant way to go. Section 6. Black holes ain't so empty. Hawking radiation. You might think black holes are just empty space, but they're not. In the 1970s, Stephen Hawking proposed that black holes actually emit radiation. This radiation, called Hawking radiation, is created near the event horizon. It's a tiny effect, but it means that black holes slowly lose mass over time. Eventually, over trillions of years, even the biggest black holes will evaporate completely due to Hawking radiation. Section 7. Supermassive giants lurking in galactic cores. Did you know that there are different sizes of black holes? Some are just a few times the mass of our sun, while others are millions or even billions of times heavier. These supermassive black holes are thought to reside at the centers of most galaxies, including our own Milky Way.